That looks like more than normal, doesn't it? Oh my god, Tiano Core! What? Oh, press escape for boot options. I can't believe it. Oh, it works.
The happiness.
Alright, welcome everyone to another video, and this one's very interesting. Now before I get started with anything, I need to tell you, if you've clicked on this video hoping that this is how you get your graphic card to work with your SBC, like a Raspberry Pi or RK3399 based stuff, or like a Rock Pi or something like that along those lines, this is not for you. This content is for people who have mature ARM64 systems that have either some sort of UEFI Tiano Core enablement, have some sort of systems ready specification, have decent working PCIe implementation, and not something that caps out at a bar of 33 megabytes. If that's you, if you have a teeny tiny board with a teeny tiny mobile SoC, this video is not for you. Do not go forward thinking that this video you'll get to run your graphic card on a single board computer. This is not it. Even if you have the Pi 4, if you have the latest and greatest SBC, this won't work. If you have a server grade ARM hardware, if you have AMD Seattle, if you have a Mustang, if you have something like the Honeycomb, or if you have anything again that has a mature bootloader, half decent bootloader even, this will work. If it boots U-boot, it won't. I love U-boot, but U-boot still needs to get the EFI driver game strong before they go into the server stuff. Anywho, this is if your ARM system boots UEFI and is somewhat compliant. So here's the hardware and what we are going to do, but let me just introduce you to the hardware so you just have an idea what I'm working with. This is the graphic card. This is an AMD R7 250. You can use something along those lines. You can use something newer. All you need to make sure is it's compatible with x86 UEFI. It has the U-string UEFI on it. If you look closer, I'm not sure if I'll be able to show it on this camera, but it actually says UEFI on the sticker. I've had newer cards that don't have UEFI, and this trick will not work with them. Next up is the actual board, or the actual server system. This is the AMD Seattle. It was gifted to me by my friend David from Mininodes, and it has been an awesome ARM hardware to work on. Sadly, AMD killed this project. This is an AMD ARM server chip. This is EOL as far as I know, and as great as it is, you can't buy it. Well, there's some leftover hardware somewhere, I guess. But if you have the new Honeycomb, this trick will work perfectly well. If you have anything like that, this will work perfectly well. Alright, now that we've gone through all of that, let's begin. So, what we're trying to do today is to get AMD, is to get the GPU to show the bootloader, to show the UEFI bootloader, either just booting up or go to the menu, but use this graphic card instead of a serial port. So x86 had VGA compatibility since the beginning. They never had this problem. ARM, being a RISC architecture, does not. So it's not a part of the ISA to have VGA. It just needs serial. So right, so to do that, there are two ways. All UEFI capable video cards have x86 UEFI drivers in their flash. Tiano Core EDK2, which is the UEFI implementation, which is the open source UEFI implementation, has something called an x86 emulator for ARM hardware. It was worked on by Alex. He was at SUSE at the time. I don't know where he works now, but Anywho, so Alex wrote all of this, and this allowed, and the main issue was not really graphic card but network drivers that needs to initialize and have their Mac working in order to pixie boot. Graphic card just got, I think, got the free ride, but also it was implemented by the time Syncquacer came out, and Syncquacer had a GT 710 paired with it, so could be used and built around the same time. So again, anyways, so you can use that. That's already enabled. But what if your UEFI build, which probably isn't Tiano Core, maybe it's AMI BIOS, maybe it's something else, does not have that emulator built in, because sometimes there are like licensing issues with x86 emulation and stuff like that are a non-issue usually, but like companies don't really want to get into, so they don't include that emulator in the BIOS, because that's something that ships with the device. Forgetting that, what if you want to make it permanently and reliably only boot ARM64 UEFI driver? Now AMD provides ARM64 UEFI driver on their website. It's free, you can download it, you can write it to your flash on the BIOS or load it at runtime, or you can follow this stuff and permanently write it to the graphic card, and it's an ARM64 only graphic card. It won't show on a UEFI x86 board. That's not entirely true, because it will then fall back to the VGA mode. But ARM64 only UEFI, especially this one, because I've already done it with it. So this video is about that. This is everything pre-OS boot. So OS drivers don't have to do anything with it. DRM doesn't have to do anything with it. Anything user space related does not have to do anything with it. This graphic card, even if it has the x86 and even if it doesn't display anything during boot, will work fine in Linux or FreeBSD or anything else that has the bits enabled to run a Radeon card. This is before Linux boot. So let's make this very clear. I don't want my comments or YouTube comments to be absolute garbage, right? This is mostly reversible process, but still be very sure this is an extra hardware you have or something that you're willing to part with. If this goes south, it shouldn't. Always make up a backup of your ROM before doing any modifications, and I do that in the following video. Right, something about the following video. That video was made months ago. I had David Tischler on the call, and we were pretty hysterical when it finally worked out. But again, this was months ago, and I don't remember each and every step of it. So sometimes, because I've voiced over a lot of it, again, I was in a call with someone, I didn't want to get all the audio in, so I voiced over the entire video. So sometimes I fumble around. So excuse that. That's just me trying to remember what happened many months ago. I really want to thank two people to get this working. They were the first ones to try it, as far as I know. So John Nettleton, or Linux for Kicks on Twitter, he works at SolidRun. He is the person behind the absolutely nice UEFI firmware behind the Honeycomb. So he has a lot of experience with all of that. The next person is Ard. Ard has been like this ARM UEFI god. I've always, if it's something to do with ARM UEFI, Ard is there. And you know, I've not had a direct conversation on this topic with him. I've only had I've only met him a couple of times at conferences, but again, Art was the one to mainly figure all of this out, and John Nettleton tested a bunch of it. Maybe he figured out with him, but anyway, so John Nettleton gave me all of the instructions over Twitter, and we sort of went back and forth trying it. around. His was working, mine wasn't working for a while, and then I figured out what was wrong with it. Anyway, yeah, so I tried a weird Power Color RX 550 card, which did not even have the UEFI bias, which makes a bit of a problem because then there's a possibility that the overall firmware isn't aware if it's requested with the EFI driver where that should be. So even if you put the EFI driver there, it won't know that it's there. Anyway, so most of the cards from decent companies should have it. I think this one's from Sapphire. Sapphire is good, MSI is good, Asus, Gigabyte, Zotac, all of the major ones are fine. Right, let's get to it. Too much prelude, but it was necessary to like warn everyone to what they're getting into. The comment section might be a disaster still, but right, let's go to it. Alright, so for now, I am just going to boot it. Forget what's on the screen right now. That's logged from a previous boot, but right now, what I'll do is try to load the EFI driver from shell and not have it load from the SPI flash itself. So that's the process we're going to go through in the rest of this video, but we just wanted to see if the driver works. So now that the Seattle has booted, I'm in the UEFI boot menu. Just ignore the weirdness that's happening. Only take note that we are logging into the UEFI shell. I have a USB disk, or I think it's my primary hard drive, I forget. But anyway, FS0, we have the ARM GOP driver, and as soon as I load the GOP driver, you can see the root shell appear on the Aarch64 Seattle screen. That screen is directly piped through the HDMI port on the GPU that's attached to the Seattle machine, and on the x86 host is showing the serial output. So now we go into booting that with the driver loaded, booting Fedora. So right now what all you are seeing on the screen is from the EFI driver, and as soon as FB0 comes up, it switches to that. So now it is switching to the internal the Linux Radeon driver. So that's how it works. If the SPI flash contains the EFI driver, you don't have to worry about loading it manually, and it will show a lot more things in the UEFI boot menu. So going forward with that, quickly log in. Alright, so first order of business is to SSH into the Seattle system. So on the x86 host side, what you are seeing is SSH'd, and then on the Seattle side, it's the display. Anywho, so next up, we will read the ROM, and this is a special flash ROM build that has ATI SPI, so ATI card SPI devices enabled. And the build I have didn't have the correct device ID for the card I use, so it complained about that. So again, flash ROM upstream does not have support for ATI GPUs to get the SPI flash, so you need a special branch of it. I'll link it in the description, but that branch also doesn't have the correct ID for R7 240 and 250 systems, 250 GPUs. So for those particular GPUs, it has for most of them. More or less, the newer RX 500 series would work fine. Anything newer would work fine, but that particular GPU wasn't there. So I think it had like 6784 and we needed, or like 6840, and we needed like 6837 or some ID along those lines. So that's what I'm doing, is to add that, and I've opened the source code, the ATI-SPI.c, that has all the device ID definitions and some code related to specific families of GPUs. So that's where you add your ID, and let's find that. So that's the 6840. I think we need 6837. So let's go ahead and add that, and So sorry, 683F. There you go. Again, this is a voiceover, so anywho, now we go build the latest version with our changes in it. So and here's one of the mistake I did. It's the architecture is not like ARM64, it's just ARM, so you need to specify that, otherwise it takes ARM64 as default and doesn't build. So anywho, it's built now. Now we can just use a flash ROM command, as simple as that. It'll detect everything else automatically. You just have to set the programmer as ATISPI, and that's it. It's given us our ROM dump from the GPU, and we can use EFI tools to check that out in a second. So that would be EFI ROM D R7250 stuff. So you can see the image 2 is the one we need to change. That is the EFI image, and if you see in the ROM header contents, that is set to X64. So what we need to do now is to go ahead and sort of change our ROM, our EFI driver into a ROM data partition, I guess, with the correct device ID. So as soon as we press enter, again the EFI ROM utility will do that for us. Now we can decompress this particular out.rom file that we created, and that is basically our image 2 in the main ROM file. So as you can see, that shows up as Aarch64 or AA64 ID. Now here's where things went a bit south for me. So copy everything from the original ROM file, so that you always have that in case things go bad. And just now we'll just work on the other file. So this is a fast forwarded clip of me going through issues. I had the offset size wrong. So what you are seeing now is just me trying to go through and understand the offset sizes correctly. DD has weird ways, like it will overwrite some places it won't overwrite. It has weird flags for seek and to overwrite or write from correct place or write till that particular area. So the thing is, the offset we want is 10,000 in hex, and I put the seek right at 100, but block size needed to be 256, which is again 100. So you multiply those and you get 10,000. So I had block size at 128, which is not that. So all I needed to do was change the block size to 256. That gave me my correct seek. And once I press enter, and now I ran EFI ROM, the entire ROM is now Aarch64. So that made my life easier. And now you can see I had just opened up Bless to just check whether the correct image headers and everything were in place and showed stuff correctly. I was comparing to that stuff. So now we can just simply go into Flash ROM and write it all to the card. And just a simple write operation, and we select the file. So this time it's R7250-ARC64.ROM. This has the EFI driver add image to offset 0x10000, and that's it. That's done. Erasing and writing flash chip. It's a fairly quick thing to do, and yeah, so you can just like get these EFI files and do it for a bunch of cards that you have. Just make sure you have the correct EFI driver. AMD provides them for free. Right, power off, and now let's see the magic happen once it starts to reboot. So switching over to serial on the host side, and so Seattle takes a while to boot. It has ECC memory, so it goes and either trains it partially or just scans if everything's working. Does a quick scan if everything's working nice, because training itself will take quite a lot of time. So yeah, usually you just sit here, wait for it to boot. And that has started booting. It has started booting a bit more. And now it's loaded the GOP driver, so you can see the Tiana Core logo. You can see the wait progress bar, and you can like press escape to go into the boot menu and everything, like just like a regular PC. And I just did that, and it opened up this menu again without having to manually load anything. Now I did kind of mess up. All right, so it has the right, so let's boot into Fedora first. And you can see the Plymouth boot screen doesn't really come up. It just starts loading the kernel and waits for a bit and switches over to the Linux driver, which is fine. But I really wanted to see the loading logo, and I've seen that before, like it works just fine. But in this particular install, I messed something up, and like the whole quiet and flicker free boot did not work, which it is supposed to work in the system, and it has worked for me before in the same setup. So anyway, I tried to repair that. I don't remember what I changed, and at this point I just don't have that original install as well. Like that SSD is gone, which is running on this system. So let's reboot and see it working again, because honestly it is quite magical to have a consumer grade GPU just work on ARM64, provided that you have a server set up and not a Pi. Basically, that never works. But yeah, let's just see it boot once more. And there you go, it has started to boot. And here it is, the UEFI bootloader yet again. So I think let's set the console to serial so that it just moves into. So this is part of the flicker free stuff, but not really. This is as much as the UEFI BIOS can do. So it will go straight from EFI to login without the Fedora logo. But if you have everything correctly set up and it's a fresh install, then it shows that Fedora loading screen with the Tiana Core logo. Anywho, again, that didn't work, and I am not going to force it to work. So just moving around, EFI bootloader looks just fine on this GOP driver. Reset it, wait for it to boot, and it goes booting again. And here's the magical Tiana Core logo. Like this, you can't get enough of this on a ARM64 device. And again, something that's not Pi 4. And as you can see, it's just straight up booting on the serial. It's straight up spitting out the boot log on the serial, and as soon as the GNOME display manager starts up, and it goes straight into login. Not quite flicker free yet, but again, as I said, I messed up the settings. So there you go. That's working. A graphic card spitting out Tiana Core UEFI on an ARM system using a native ARM driver. Now, if you have an NVIDIA GPU and you have a fairly good build of UEFI, or even it will still work because it has the emulator, the x86 emulator. A lot of Tiana Core builds have that built in, so it loads your x86 EFI driver and makes it work just fine. I don't know if I have quite done a video on that yet, but it actually works just well enough. And it was done during the time Synqueza come out, the Synqueza developer box came out. And yeah, that was a thing that happened. Anywho, so I'm just going to keep on trying it because it is such a good experience that all of this works. So again, there is Tiano Core booting, and you can have that on a lot of dev boot these days, sadly. But if you have a good ARM64 system that has some server class or networking class um, background, or like breed, then it will work. Basically, you need to have close to systems ready compliance, specifically with like PCIe and IOMMU. Otherwise, things can go south for PCI graphic cards or any sort of PCI expansion cards. Anything greater than a simple network adapter or a simple SATA driver. Those things are simple to drive. But like when it comes to like graphic card or high class networking, that's where you really want a good solid PCIe IP in there. Anyway, and this is the Seattle, so AMD made it. They knew what they were doing. Sadly, it didn't last too long. Yada yada yada. Anywho, thank you so much for watching. I hope it was somewhat educational and you could loosely follow and do it with your own GPU. I've tried to make it so it's completely reversible. You basically read the ROM file, and if anything goes south, you can flash the original ROM file back, and it will always work. But do it in your um, own peril. It might break your graphic card if you don't do it right. And I had a bunch extra lying around, so I just did it basically. Anyways, thank you so much for watching, and I will see you all in the next one. Bye.